let's solve some equations to see how the properties of equality are applied. First, let's try to solve 5x minus 8 equals 2x plus 7. Now, applying the properties of equality, what we can do is to try and eliminate the negative 8 from the left side of the equation, and we do that, remember, by adding its additive inverse, which is, of course, positive 8. And we have to do that on both sides of the equation. So we add 8 on both sides of the equation because adding 8 on the left side, in particular, eliminates the negative 8 term because 8 plus negative 8 yields 0. So on the left, that becomes 5x, and on the right side of the equation, that's 2x plus 7 plus 8, that's plus 15. Next, let's try and eliminate 2x from the right side of the equation. To do that, we need to add the additive inverse of the term 2x, and that, of course, is negative 2x. Again, remember, whatever you do to one side of the equation, you must do to the other. So I also add negative 2x on the left side. So the right side then becomes just 15, and the left becomes 3x. Finally, to isolate the variable x, we need to eliminate the multiplier 3. To do that, we multiply both sides of the equation by the multiplicative inverse of 3, which in this case is 1/3. So we multiply both sides of the equation by 1/3. So the left side becomes just x, and the right side is 15 times 1/3, or in other words, 15 divided by 3 is 5. Next one. What about the equation 4x minus 3 equals 2 multiplied by the quantity 3 minus 2x plus 1? Right, so let's apply our properties of equality as well as some properties of numbers that we have learned from the previous module. So what I can do here first is to multiply 2 to the quantity 3 minus 2x, applying, of course, the distributive property of multiplication over addition. So I'll have on the right side 2 times 3, that's 6. And then 2 times negative 2x, that's a minus 4x. And then you have your plus 1 at the end. The left side is 4x minus 3. At this stage, we can combine our like terms. If you see the left side of the equation, we can't really add 4x and negative 3. But on the right, I can combine the 6 and the 1. So the left side, for now, stays as is, but the right side becomes, that's 6 plus 1, that's a 7 minus 4x. Next, what we can do here is to combine the similar terms. I can try and eliminate the negative 3 from the left side, and to do that, I need to add the additive inverse of negative 3, which is 3, to both sides of the equation. The left side becomes just 4x, and the right side becomes, that's 7 plus 3, that's 10 minus 4x. Next, we can try and eliminate the negative 4x term on the right side by adding its additive inverse, which is 4x, to both sides of the equation. The right side becomes just 10, while the left side becomes 8x. Finally, we need to eliminate x, and since it's a multiplier, we need to apply our MPE and multiply both sides by 1/8. 1/8, of course, is the multiplicative inverse of 8. So the left side becomes just x, and the right side becomes 10 over 8, or in its simplified form, 5 over 4. Right. Next equation. Let's try and solve the equation 0.1x minus 2 equals the negative of the quantity 5 plus 0.2x. Now, don't be scared that we see some decimal numbers here as multipliers of the variable, because after all, they are just numbers. So again, don't be scared of decimal numbers. So the first thing we can do is to apply, if you look at the right side of the equation, what we can do first is apply the definition of the opposite of a sum. So I will keep the left side for now as 0.1x minus 2 equals, and then the right side, again, I apply the definition of the opposite of a sum. That becomes negative 5 minus 0.2x. Now, we can of course combine the similar terms as we did in the previous examples. But if you didn't want to work with decimal numbers, we can be strategic in terms of using the properties of equality. In particular, we can use very strategically our MPE. In this case, what I can do is multiply both sides of the equation by 10. Now pause for a bit and think, why do I need to multiply both sides of the equation by 10? And why 10? Why not just any other number? Right, now if you look at what the effect of multiplying 10 by these decimal numbers is that, note how when I multiply 0.1x by 10, I'm effectively moving the decimal point of 0.1 one place to the right. Because if you might remember from your grade school, that's how multiplying by powers of 10, like 10, 100, or 1000, does to a certain number. So in that case, if I apply the distributive property of multiplication over addition on both sides of the equation, the left side becomes, that's 10 times 0.1x, that will become 1x, or simply x. And then 10 times negative 2 is negative 20. The right side becomes, that's 10 times negative 5, that's a negative 50, minus, that's 10 times 0.2x. Again, we move the decimal point once to the right because our multiplier, a power of 10, has 1 0. Remember that from your grade school days? So that becomes 2x. Now note our next line here. We are now just working with integers as either multipliers or add-ins. So again, we can combine the similar terms. First, I'd like to eliminate the negative 20 from the left side. So to do that, I add 20 to both sides of the equation. So the left side becomes just x, and the right side becomes, it's a negative 50 plus 20, that's a negative 30 minus 2x. Then what I can do now is to add 2x on both sides of the equation to eliminate the negative 2x on the right side. So the left side becomes 3x and the right side becomes just negative 30. Finally, we multiply 1/3 by virtue of the MPE to both sides of the equation to eliminate the multiplier of x. So I have x equals negative 10 for my final answer. Right, last equation. Let's try and solve this equation. X minus 1 all over 4 minus x plus 2 all over 6 equals 1. Now, again, it appears like we have fractions here, but more complicated looking fractions. Again, don't be scared of fractions. Don't be scared of decimal numbers. They're just numbers after all. So what we can do here, we see that our two fractions have denominators 4 and 6. So maybe we can be strategic about this and again apply MPE and multiply by a certain number that, after multiplying, would probably eliminate our denominators. Now again, pause for a moment and think, what could be the best multiplier in this case? Right, we can choose to multiply both sides of the equation by a very special number, which is, if you can recall, our LCD, or the least common denominator of our fractions. In this case, the least common denominator of our two fractions on the left side of the equation is 12, which makes it our best multiplier for this equation. So the first thing we need to do is to apply the distributive property of multiplication over addition on the left side That's 12. Let's do this step by step. 12 multiplied by x minus 1 all over 4 minus 12 multiplied by x plus 2 all over 6 equals, now again, we need to multiply 12 also to the right side, which makes it 12. Now, note the left side of the equation. This might look a little intimidating, but it's actually not. What we can do first is to try and cancel out common factors. We see 12 here and a 4 at the bottom. Remember how we can cancel out the 4 from those two numbers because 4 is a common factor. So I'm left with the 3 as a multiplier here in the first term. And on this second term, you have 12 and 6. Now again, I can cancel out the common factor 6 to be left with 2. Isn't that the same thing that we did when we dealt with fractions? So once we do that, the left side now becomes 3 multiplied by the quantity x minus 1 minus 2 multiplied by the quantity x plus 2 equals 12. Now again, let's apply the distributive property of multiplication over addition twice here on the left side. We have here 3x minus 3 minus 2x minus 4 equals 12. Now let's try and combine the similar terms on the left side. I can combine the 3x and the negative 2x to yield just x. Negative 3 plus negative 4 is negative 7. So I have x minus 7 on the left side and 12 on the right. Now finally, to eliminate the negative 7 on the left side of the equation, I simply need to add 7, its additive inverse, to both sides of the equation. Again, that's by virtue of your APE. So the left side becomes just x, and the right side becomes 12 plus 7, which is 19.